Hey, welcome to You'll Be Blessed Education. This is You'll Be Blessed here, or AKA Mr. Phillips in the chemistry classroom. And today you are joining me for a lesson on multiplication and division with sig figs. All right. Now, if you have not checked out my previous video on the identification or classification or the counting of sig figs or significant digits, then please make sure you watch that because it is crucial when it comes to learning how to multiply and divide and then using the rules of significant figures to round. Okay, so ultimately the goal is to determine the number of sig figs in a measurement and then apply the rules of sig figs towards scientific calculations. And we do this using logic because logic determines the representation of our measurements. It just makes sense to round our measurements a certain way based on how many numbers are significant in our measurements. All right. So we're going to state the number of sig figs in each one of our measurements today, and then we're actually going to show how that leads to multiplication and division and choosing the appropriate number of figures to report in the measurement. All right. So here are the rules. Count the sig figs. Again, previous video, that is so important. Now, here's what ultimately determines how a final measurement is represented in a calculation, at least with multiplication and division. The lowest number of sig figs determines how many sig figs the final answer will have. Why? It's because your final answer can only be as good as your worst measurement. So if your worst measurement, if you have two measurements, one with 5 sig figs and the other one with 3 sig figs, remember sig figs represents the number of digits that are certain and guessed. So a number with 5 sig figs has 4 certain digits and 1 guess, totaling up to 5. While the other one that has 3 sig figs, meaning it has 2 certain numbers and a guess totaling up to 3. So your final answer can only be as good as your worst measurement. And your worst measurement is the one that has the least number of sig figs. So with 5 and 3, 5 and 3, 3 would be the worst measurement, okay? And if calculations happen to be done in sequence, so if you're doing multiplication, division, division, multiplication, like in a row, then you just simply round at the end of the calculation, okay? So let's begin. Here's our first example. We have 12.257 meters times 1.162 meters. And so our first step is to count the number of sig figs in each measurement. And therefore, if we do that, we're going to get five, um, 5 sig figs in the first measurement and then 3 sig figs in the second measurement. Which one? I'm sorry, not 3, 4, excuse me. Let me actually pull up my notes when I'm actually doing this. All right. So 5 sig figs in the first measurement, 4 in the second. Which one has the least number of sig figs, or what's our least number? It's 4. So when you put this into a calculator never rounds for you. It just spits out every single number. But our brains can only tolerate so many numbers and make sense of so many digits. Okay. At some point in time, a certain amount of digits becomes meaningless. For example, the most at, on average, the average human being can remember about 9 to 10 numbers at a time. That's about the length of a phone number. Okay. So again, that's average. I'm not talking about memorizing all the digits of pi or the first 30 digits of pi. I'm just talking about an average, everyday, ordinary number that you're not familiar with. Okay. So let's take this calculator number and put it into something reasonable that our brains can actually process. So we got 14.2426234 meters squared, because the meters multiply, dimensional analysis, you get meters squared. Okay. And so that means the final answer needs to have 4 sig figs because our worst measurement is 1.162 meters. And so when you do that, you're going to keep the first 4 digits, but make sure that last digit is rounded. Okay. So the first 4 digits or sig figs of this number are 1, 4, 2, and 4. The 2 that is after the 4 in 0.24, okay, means we're going to round this number down. So that's why we only keep the first 4 digits. And that 4th digit is rounded based on the 5th digit or the digit that follows. So 14.24 meters squared. Okay, now this actually makes sense. This is telling us that the only numbers that are important in this calculation are the first 4. All the other numbers after that are meaningless. So let's move on to our next example. Here, we're going to look at division. 3.05 grams divided by 8.472 milliliters. Okay, so the first thing again is we're going to count the number of sig figs. The first measurement, 3.05 grams, has a total of two non-zero numbers with a sandwich zero that takes us to 3 digits, while the second measurement, 8.472 milliliters, has 4 non-zero digits. Therefore, it has 4 sig figs. So 3 and 4. You take those two numbers, you divide them. This is like calculating density or concentration. Okay, mass divided by volume. You get grams per milliliter as the unit, but then the calculator output is 0.36000944. Okay, now like I said earlier, all those numbers don't even make sense to us. And so it's our job to use logic to determine which of those digits actually contribute meaning and then eliminate the ones that don't contribute meaning. All right. So we ask ourselves how many sig figs is in our worst possible measurement, and it is 3. So 3.05 grams has 3 sig figs. It has lower sig figs than the volumetric measurement, and therefore the final answer can only have 3 sig figs. Therefore, we're going to keep the first 3 sig figs. The 0 in the front doesn't count. Remember that. So we start with 3. And so our final answer is 0.360 grams per milliliter. So we keep the first 3 sig figs, 3 and 6, and then the 0 that is after this decimal counts because of the I believe it's the fourth rule. The fourth rule that I introduced in the last video is that all trailing zeros after a decimal are significant. So 0.360 grams per milliliter. And of course, 0 rounds down. The following 0 rounds that 0 down. So that's why we don't change it. Okay. So this answer has 3 sig figs. All right. I hope you've enjoyed this video. I hope you were blessed by this video. If you have been, please leave a comment telling me how you were blessed about it or blessed by it. Excuse my language. Okay. And if you are looking forward to perfecting your abilities in the chemistry classroom and learning more chemistry content from me, then I highly suggest that you like this video so that I'm encouraged to make more videos, as well as hit the subscribe button and the notification symbol so that whenever I upload more videos, you will get that notification. All right. So again, this is You'll Be Blessed, aka Mr. Phillips in the chemistry classroom. Have a great day. I'm out.